Welcome to the second session of this Legacy of Socrates conference, remote conference. Now we're having Ernesto. Ernesto is the founder of Ombu Labs, which is a company that is dedicated to building lean code and addressing existing code, reducing tech debt, really focused on Ruby on Rails language. So that's the language Ernesto will be using to present you code complexity measures and a way to measure code quality so you can prioritize what technical debt to address. Ernesto will be using examples in Ruby on Rails, but obviously you can apply these examples to your own specific language. Thank you, Ernesto, for being here, and I'm ending to you.
All right. Well, thanks for having me. Yeah, first of all, a big thank you to Adrian and Nicholas for organizing this remote conference in such a short time. And I'm so happy to be here. Yeah, so I'm going to be talking about the tar pit, and there's going to be two parts to this presentation. The first one is going to be how to avoid the tar pit in the first place. And then the second part will be, okay, how can we get out of it gradually and in a measured way? Yeah, my name is Ernesto Tagwerker. You can find me on Twitter, GitHub, and basically anywhere with the handle eTagwerker. If you have any questions, there is a little button that says add a question, and you can just use it to record it there. And then at the end of the presentation, I can take a look and see if I can answer them in the best way. All right, so let's get started. Yeah, I am originally from Argentina. So if you hear any words that sound funny, it's because I have a bit of an accent. I have been living in Philadelphia for the past 3 years. And yeah, I really like it here. It's a really nice city. And another thing about me is that I love open source. I've been using it for years, and I've been contributing for maybe the past 8 years. And I wouldn't be here today speaking if it wasn't thanks to open source. Actually, about 99% of the code that I'm going to talk about today was not written by me, but it helps me get the job done and basically have a good life. So anyway, I like to maintain some Ruby gems out there. And if you're not familiar with Ruby, a gem is a library. So every time I say gem, just think library. And if you're in the Ruby world, you might have used some of the tools that I built over the years. A few years ago, about 9 years ago, I founded a small software development agency called Ombu Labs. And we like to work a lot with Ruby, Rails, JavaScript, and open source in general. Now, a few years ago, we found ourselves doing a lot of Rails upgrade projects. So we decided to launch a service called .io. And a lot of the insights that I'm going to share with you today come from our experience doing this productized service. Basically, clients come to us to get their application to the next version of Rails. And quickly, we need to determine whether we want to take on the project or not. Because we don't want to get stuck in the tar pit and basically be stuck in the Rails upgrade project for years. And there are a few considerations that we need to look at every time we evaluate a project. So anyway, part of the insights in this talk come from our real life experience shipping upgrades for clients. Now, the inspiration for the title of this talk, Escaping the Tar Pit, comes from one of my favorite books by in the Mythical Man Month, the very first chapter, he talks about the tar pit. And I think we're all sort of familiar with this idea of like prehistorical beasts getting entangled in the sticky tar. And I like the analogy he makes. He talks about large system programming being stuck in such a tar pit in the past decade. And then he goes on to say, and many great and powerful beasts have thrashed violently in it. And he's talking about the past decade. But the truth is that this book was published in the 70s. So when he's talking about the past decade, he's talking about the 60s and the 70s. And I think it's fascinating that to this day, we still see some of the problems that he describes in that chapter. And then he goes on to talk about, the fiercer the struggle, the more entangling the tar, and no beast is so strong, skillful, but that they ultimately sink. And I think if you've been around the block for a few years, you have felt this feeling and you have been stuck in those projects. And I think we're in either two states. We're either in the tar pit or we're trying to avoid it. And when we are in the tar pit, we're trying really, really hard to get out of it, right? Nobody likes it. So as software engineers, what we want to do is make changes that will get us out of it. And I like what Tobias was saying earlier today about the big ball of mud, right? We want to get out of the big ball of mud, want to make it better. But sometimes our efforts look like this. It's like we try, and sometimes we just get even further down the tar pit. And of course, the Simpsons have like the best skit for this. So let's come back to reality. Like, where do we see the tar pit? Well, I believe there are 3 examples that are very clear. Projects running over budget, saying you're going to ship this set of features in 3 months, and then 6 months into the project, you still have no idea when you're going to be done with it. Taking forever to ship small changes. Basically inheriting a legacy project and getting your client to come up to you and say, hey, how long is it going to take you to ship this one small feature in the home page? And you say, yeah, sure, it's going to take 1 day. But then a week goes by and you're nowhere near getting that done. And then the client is like, why is it taking so long? Like, the application works. Why is it taking so long? And then you have to explain that it's this sticky tar pit. And then a classic one, right? Sacrificing quality, increasing technical debt to be paid off later. But we all know that later never comes because you need to ship features, you need to ship patches. And I'm here to tell you it is not fine. Like, it is not fine to be in that situation, and you can get out of it. And this little dog in the GIF should basically get a fire extinguisher or get out of that room because you're about to get burned. All right, so the talk is about avoiding the tar pit in the first place. Basically, not getting into projects that are going to be a huge mess. And part 2 is going to be about getting out of the tar pit, because sometimes you're working in your job and sometimes you will come up to you and they will tell you, you need to maintain this legacy project. And you really like your job, you like your benefits, you like everybody in the company, and you have to deal with it. So how can you use what you learned in part 1 to get out of the tar pit? All right, so let's start. Boss comes up to you and they tell you, yeah, if you could come in on this great legacy project and maintain it from now on, that would be great. For us at fastruby.io, usually looks more like a client telling us this. It's like, yes, this project is great. It's running in production. We just need you to maintain it from now on. Now, before you commit to anything, think about the next words out of their mouth. How long is it going to take to do X? And you know that right after that, you'll hear something like, yeah, because I need it by end of day today. So before you commit to anything, how can you quickly assess code quality? How can you say this project is salvageable, or this project should be rewritten. In the Ruby world, there are basically two ways to do it. You can pay someone to give you an idea of code quality, or you can use open source libraries for it. Now, I'm not here to sell you on any services, so we are going to focus on a few open source libraries that are out there and that are great. And these libraries are going to do a bunch of things, but mainly the three most important categories are static code analysis. They will read every statement in your application, and they will assign a complexity score to every module in your application. They will measure how many statements are exercised by your test suite. They will tell you, yes, your test suite covers about 70% of your statements. They will look at code smells. They will look at your code base. They will look at the complexity in the files, and they will compare it to a known database of code smells. And then they will tell you this module has 27 code smells. And all these things are signals to tell you how well maintained the project really is. And that will give you an idea of software quality. And I know I keep talking about quality and software quality, and I know that this is a tricky subject. Like, there are hundreds of definitions out there. And here's a small rant, and I promise it's the only rant. Just because there are hundreds of definitions out there, it does not mean that you can throw your arms up in the air and say, this is too complicated. We can't deal with quality. Quality is subjective, so we're not going to talk about it. That's just going to make things worse in the long run, in your team, your process, and we can do better than that. The truth is that, yes, software quality is subjective, but you can define your own baseline. You can say in your team, this is the baseline of software quality that we're going to ship. And every time you submit a pull request, your change is going to be measured by this baseline. All right, end of rant. I assume that if you're here and listening to this, you care about software quality and you're not throwing your arms up in the air like Seinfeld there. All right, but yes, let's see a couple of definitions. Like the IEEE says, it's software quality. It's the degree to which a system, component, or process meets implicit requirements. And yes, this definition is bulletproof. It was designed and written by a committee of very talented people, and it covers everything. And to be honest, it sounds to me like expected. But it's not just that, right? Like maybe an application is running well in production and the client is happy, but software engineers don't want to maintain it because it's just too complicated. So I think it works as expected, and it is not a pain to maintain it. So when I'm talking about software quality in this presentation, think more about one of the factors of ISO 9126-1. Think about maintainability. Maintainability, I want to talk about two concepts that are very important, and the order in which I mention them is important. First is code coverage. I care about this. This is a signal that is important to me because it's telling me that there is a test suite and that it covers more than 0% of the statements in the application. And then I do care about code quality because I want to make it better. I want to get out of the tar pit by refactoring modules. I'm not going to go into refactoring a module that has 0% code coverage. You can, but I choose not to because I choose not to put out fires over the weekend, and I choose not to do a lot of manual testing for features, which that would be the alternative. So in the Ruby world, we have a bunch of tools that are really cool. We have SimpleCov. that is a little gem that you can install in your project. And if you're in another tech stack, I'm sure there are tools out there that will do this for you. You install it like this, and you run it like this. And what it does is it generates an HTML report that looks like this. And this is a little signal about the project. It tells me that 82% of the statements are hit by my test. Now, it doesn't tell me if they're good tests or bad tests, okay? But it does tell me that they're exercised. Now, for code quality in Ruby, they have a lot of options. And it's related to what I was saying. There are a lot of definitions for software quality. So you have things like flawed, flay, Critic, Rubacop, and others. I decided to go with Ruby Critic because if you're familiar with Code Climate, it is very similar to Code Climate, but it's open source and it's really active when it comes to accepting new contributions. Ruby Critic takes into account two concepts mainly. It takes into account a lot of concepts, but churn and complexity are the two that are most important to Ruby Critic. Now, churn, fortunately, we have Git, and Git can tell us how many times a file has changed since the beginning of the project. We can basically run something like this, and it will tell us, yeah, default.rb has changed 3 times since the beginning of the application. And this will tell us that the churn count for this is 3. Now, in itself, the trick is not that useful, right? It tells me what files are constantly changing, but you can't really gather insights from this one metric. It starts to become interesting when you combine it with complexity. Complexity is, Ruby Critic uses a gem called flog. And with flog, you can basically run flog default.rb, and it will give you a complexity points total. And what it does is it measures a metric for assignments, branches, and conditions. So if you look at the values in there, you'll see that an assignment is worth 1.2, an eval is worth 6.0, a condition is worth 1.2 plus the condition, which is 1.2, and so on and so forth. So what it does is it evaluates every single method in every single module and gives you a complexity score. So 10.8 comes from. Now, in itself, complexity is also not that interesting, and you can't gather insights and take action based on solely complexity. But when you combine churn and complexity, then it starts to become interesting. And you might be familiar with this graph already because you've read articles by Sandy Metz and Michael Feathers who've written about this. And yes, if you're interested in this, please go and read their articles after my talk. But basically, every single file in your application is going to be placed in this graph. So if user.rb changed 2 times and complexity is 100,000 points, you'll see it up there in the upper left quadrant. And if complexity is 100 points and it has changed 27 times, it will be in the lower right quadrant. Now think that it's doing this for every single file. So we'll see an example in a few minutes. In order to run it, you can just install it as a gem and run it in the command line like this. And it will generate an HTML report that looks like this. And you're like, okay, I inherited this project, I run Ruby Critic, and what can I do with this? Like, I have no idea. Is this like a good thing? Is it bad? I don't know. Well, let's go part by part. To the left, you have the GPA pie graph. Every single module gets a GPA score. Think F is the worst and A is the best. And for calculating this GPA, it uses complexity and code smells. And then you look at that pie graph, like, okay, percent of the files are either a D or an F, but 75% are either an A or B or a C. So, okay, that looks pretty good so far. Now, if you look at the churn versus complexity graph, you'll see every single in there. And okay, what does that mean? Like, how can we gather insights from this graph? I think it's useful to draw an asymptote that looks like this to separate different quadrants. And every single quadrant requires different attention. And you can start gathering insights and basically making decisions about what your action plan is going to be. Now, in the lower left quadrant, this is great. These are files that are in really good shape because they're simple and they don't change much. So don't touch them if they're doing their job. Now, in the upper left quadrant, you'll find files that no one understands because they're super complex, but nobody's changing them. So maybe don't change them. I like what Sandy Metz says about these files. She says, if the code never changes, it's not costing us money. So maybe not your priority to get out of the tar pit. In the lower right quadrant, you're going to find files that are super simple, but they keep changing. And again, these files are not your priority because you can take a look at them and quickly grasp what they're doing. Become interesting when you get to the upper right quadrant. You find modules that are complex and are constantly changing. And these files should be your priority in your refactor project. I like what Michael Feathers says about this. He says, sometimes a class becomes so complex that refactoring seems too difficult. So what I get from this is that you want to refactor these files, but you just don't have the time. Maybe you started, but you couldn't finish. So they're not that refactor. You want to do it, you just don't have the time. And the main question that I want to answer when I'm looking at this graph, the churn versus complexity graph, is, yes, are we getting ourselves into the tar pit? Is it a dumpster fire, or is it truly a maintainable project? Sometimes it will be easier than others. Sometimes you'll find graphs that look like this. You'll be like, if you can, you will decline taking part of this project. All right, so to recap, in terms of maintainability, I talked a little bit about code coverage and code quality. And I like to think about these two aspects as signals. So for code coverage, you have one. And for complexity, you have another signal. And they're both talking about the same code base. So I don't think it's crazy to put both signals in the same graph. And these signals don't mean anything. They're just to have a visual aid for this. But what if we could calculate a third signal that combines both of them? And we like to call that signal the SkunkScore. Now, the SkunkScore is a function of code quality and code coverage for every single module. And the main idea behind this is that complex files which lack tests should be our top priority to get out of the tar pit. I think it's clear with an example. Let's say we have user.rb and has 10 points for complexity and 10 for smells. So yeah, let's say it has 100 smell points. Then we have account.rb with the metrics, same amount of smell points. Now, if we look at them side by side, you might be inclined to say, well, user and account are equally stinky. But are they really equally stinky? You can't really come up with that conclusion because you're missing information. you're missing information about the test suite. So what if I told you that user has no tests? And then we could come up with a SkunkScore, that it's instead of 100 smell points, it's 10,000 skunk points. And account.rb, what if I told you that account.rb has perfect code coverage, has an integration test that covers everything? Well, if you look at them side by side, now you can get more information and get an insight about the two files. Yes, user is considerably stinkier than account. And maybe, just maybe, you should write some tests for user.rb. But you see, now you can start getting ideas for what to do next based on all the information. So what we wanted to do at fastruby.io was to automate this. So we came up with the SkunkScore calculator. And this thing, what it does is it on top of Ruby Critic. You can install it like this and run it like this, and it will generate a table that tells you what is the stinkiest file in your project, and it will sort all the files by their SkunkScore. And it will give you some more insights. The one that's really important is probably the SkunkScore average, because it will tell you whether you're going in the right direction or not. And what it does is it builds on top of Ruby Critic, which has a cost function that calculates the points based on smells and complexity. This comes from Rick and this from Flog. Now, Skunk uses the cost function to either punish it or not, depending on whether it has perfect coverage or not. And it's pretty simple. The penalty factor is basically lack of coverage. So now we have three signals, and now we know where we are when it comes to the tar pit. Now that we know where we are, we can make decisions to get out of it in a gradual, measurable way. That's what part 2 is all about. And I'm going to have to speed through this because I'm running out of time. But it builds on top of part 1. How can we gradually pay off technical debt? Well, there are 3 basic strategies: removing files, refactoring, or increasing coverage. For removing files, we have a tool called CoverBand. It's very similar to SimpleCov, but it uses real production usage to tell you whether a file is getting hit or not. So if a file is not getting hit, remove it, and that will definitely improve your SkunkScore average. Refactoring files, for sure. Go back to the graph. We see 4 different files in the upper right quadrant. And these are great candidates for refactoring. But which one do you pick out of the 4? Well, I'd say that churn versus complexity is not enough to prioritize, and you can use the SkunkScore table to one that you want to refactor. And you want to pick the ones that have decent code coverage. So if you pick the first one, get.rb, you can say, okay, I'm going to refactor this one. This is the stinkiest file. You will have to do manual work where you will have to analyze this file and find the responsibilities. What if it had 2 responsibilities? What if it fetched get data? And what if it calculated the churn count after that? Well, you can refactor and get rid of that one file. And you will find the 2 files move to the left because churn will be 1 for the new files. Then compare it to master, and you can see this average skunk score go down about 10%. To share this data with other stakeholders. And the final one is increasing coverage. Now, if you look at the table, you can find all the files that you care about and the ones that have 0% code coverage. The first one could be rake task. This is a file that you care about and has 0% code coverage. And Skunk doesn't support it yet, but the idea would be like, what if you added 50% code coverage? How much better would the SkunkScore average? Things up, in terms of maintainability, we care about code coverage, complexity, and smells. And we want to think about SkunkScore as a new way to communicate about tech debt. Okay? We want to have better conversations about this. Next time you submit a pull request, instead of saying, yeah, I paid off some tech debt with this PR, you can actually say, I paid off 5% off our tech debt with this PR. Next time you evaluate a project, instead of saying, yeah, I looked at it and this project is in pretty good shape, maybe you can say, well, this project has a skunk score of 120 points. So we can have better conversations about this. The good news is that SkunkScore and Skunk is basically open source. Every single piece of code is out there and available, and it uses a bunch of other libraries that are open source. And it is configurable. So you can use your software quality baseline to configure the tool to live up to your standards. So think about this tool and metric as your compass to get out of the tar pit. Please gradually pay off. So over time, you will see the SkunkScore average go down. And if you don't, and you see that grow exponentially, then you'll know something going on with the project. Technical debt by a lot over time. All right, thanks a lot for your time. Sorry to go past my time. If you want to know more about Skunk, go to GitHub. You'll find it there. If you have any questions about Rails upgrades, askruby.io. We share a lot of content about that. And if you have any questions and you don't get to ask them today, feel free to ping me on Twitter. I'm happy to respond there. Yeah. Oh, and there are stickers, but we'll have to wait for that. Thank you. And here are some resources. All right, I'm gonna stop sharing so I can see any questions.
Yeah, thank you very much. So we're waiting for questions. Actually, we still have some time. So if people do have questions, you do have time for Q&A. Otherwise, it will be a longer break. Yeah, they will probably come in. We have a 20-second delay between the time we talk and the time you see the content. So that's why.
Cool. Yeah, I see that there's one question. Should I guess I'll go and answer that one. Pete is asking, Nice tool, is it ported into any other languages other than Ruby? Do you know? Yes, I know that it hasn't been ported to any other languages. And I don't know if there are any other tools out there that combine code coverage and code complexity and code quality data. I think it's might be like a controversial topic, to be honest. I've gotten feedback that has been both positive and negative. Like sometimes people do not believe in code coverage as a metric to give you any value. And I think it can add a lot of value to deciding whether you take on a project or not, and whether you refactor a file or not. So always happy to talk about ideas for this project and see how I would port it to a language in the GitHub project. So feel free to to submit an issue in that project. There is another question that is similar. Any tips for similar projects for other languages? Oh, cool. We have a couple more. I think that question was answered with the last response. There are tools out there. Sure, that are tools for calculating code coverage and calculating complexity and code smells for different projects in different languages. I don't know if there is a tool that will combine all of the metrics into one single metric. What about mutation testing? Yeah, mutation testing, I don't have enough knowledge to have a solid opinion about mutation testing. I think it's a technique that could be very useful for figuring out whether a test suite is actually good or not. As I said, SimpleCov in Ruby just tells you what statements are exercised by your test suite, but it doesn't tell you whether the expectations are good or, if you remove some lines in your code base, if the tests continue to pass, which is sort of what mutation testing would do. I haven't explored that. That would be interesting to evaluate the quality of the tests for a project. Okay, cool. Another question. Are there cases where the skunk score is low, but the project is to extend and maintain? Yeah, thanks for your question. It's a really good one. I still need to do some work around this. It's a tool that I launched and open sourced it, and I've been sharing it mostly with the Ruby community. But the projects that I'm evaluating usually show up a skunk score average that is useful for looking at like the complexity over time for a project. Sometimes it shows like files that are there and are complex and have changed a lot, but they're not really getting used. And but I think part of my next steps for this project would be to run the skunk score against a set of open source projects in Rails and Ruby, because this is not just Rails based, it's Ruby based, and compare the different skunk score averages across open source projects. If you want to help me with that, I'm also happy to get some ideas on that topic. Okay, another one. Feel free to me, Nicholas, if I'm going over my time. What coverage would be acceptable for undertaking or declining a Rails project for upgrade? It depends on a bunch of things. Like if you have a small team and you don't have a QA department, and you rely heavily on your tests, let's say like 70 to 80% of code coverage would be our threshold. We usually don't take projects that have less than 70% code coverage because we rely heavily on tests and the feedback that we get every time we upgrade a dependency, whether there is a failure or not. If the project has like a QA department and they're willing to do the manual testing for us, then we probably work on it, but it would be like an exception to the rule for us. Cool. And the last one, do you use churn in your metrics since you use it in the graph at the beginning of the presentation? One is interesting. I was using it for the skunk score, and I was playing around with changes to messy code base. And I found that if I included churn skunk score, I would get results that were unexpected. I would be like, okay, I'm actually making this code better, but this is increasing churn by 1. And then I see the skunk score go up. So a previous version of Skunk actually did take churn into account for the skunk score. And then I decided to skip that because it was generating results that were unexpected. I think it's probably should be weighed in a lower capacity if we were to add it to the SkunkScore. But for now, the SkunkScore is mainly about complexity and smells and code cover. Thanks for the question. I really appreciate your attention, and yeah, I think that's the last question. I hope you're having a safe and healthy quarantine and staying home.
Yeah. Thank you very much, Ernesto. Thank you for that.